Hello Science Alliance, it is me Lara and it is our 6th lesson on energy. I'm looking forward to this one. We're learning about fossil fuels and some of the alternatives. Next week we'll look at more of the alternatives. So we're looking at like how we get electricity, how electricity is generated and comes to our homes. So fossil fuels are oil or coal or gas. I found this big lump of coal on Whitby Beach. I have to say, we're going to talk a lot about the disadvantages of fossil fuels. It's super beautiful, isn't it? It's absolutely stunning. So they're called fossil fuels because they are the fossilised remains of prehistoric, ancient, millions and millions of years old animals or plants. So coal is just trees, basically, that were kind of living in swampy conditions and fell down and became fossilised. Apparently, this really big shiny band here, I read, is from a very large piece of wood, like maybe a big thick tree branch that fell. Do you know what? I'm gonna flip it. Get into this coal. It is really lovely. So yeah, we're burning this. Seems a shame, doesn't it, to generate electricity? So the first thing I'm going to do is just to explain to you how electricity is produced, as if you were a tiny child, which you might be. Welcome. That's fine if you are. Here's how you generate electricity. You heat some water to get steam. Here we go. There's a picture of a kettle making some steam. And the steam turns a turbine. You kind of think of it as just like being a windmill. So the turbine spins and the turbine is connected to this thing called a generator, which makes electricity flow. I've said we will learn how a generator works in a later module, but today is not that day. So all you need to know is there's something in the generator that when it spins, electricity gets produced. So the turbine is, the only reason the turbine's there is because when the turbine spins, the thing inside the generator spins, and very roughly the generator is connected by wires so that when the turbine spins, the generator generates electricity, which gets to our homes. There you go, there's a little house lighting up. Now I did that whole thing. I can't lie, it's embarrassing how long it took me to do that PowerPoint. And then I finished it and I thought, oh no. Oh, we've already learned about electricity. I am just teaching a massive misconception there. So we've got to do the whole thing again. Sorry. How you generate electricity? Concentrate, because I'm going to ask you about this in a sec. You heat up water so you get steam. It's the steam that pushes on the turbine and makes it spinny. The turbine is connected straight away to a thing called a generator. And when the turbine spins, the generator generates electricity. But it's not electrons coming out of the generator, isn't it, and travelling all the way to our house. That's not how electricity works. The turbine spins and the generator produces electricity, and the electrons in the wires sort of jiggle around a bit, and that's what electricity is. There. Right, here's a really beautiful little picture / diagram that I found of the inside of a power station. Could you please try and spot the stages that I've mentioned? So I've put heat water, make steam, steam turns a turbine, turbine's connected to a generator so electricity flows. So just like those 4 stages, have a look at this diagram and think about where do you reckon each stage is happening. I've also said, can you spot 3 things that we have not mentioned? And have a guess at what they do. So you've got what? A big metal tank. You've got some coal on like a little conveyor belt going into a fire, and the fire is above some blue stuff in a tube, a long curly tube. And above the long curly tube, the blue stuff is turning into clouds. And then the clouds are kind of going along this little corridor and getting to this big, what is that? It looks like an egg timer on its side that has been pierced by a stick. And then the little clouds are turning into rain and filling a sort of swimming pool underneath the egg timer on a stick. And the egg timer on a stick is also connected to a little grey box, which is connected to a larger grey box on wheels, on like sticks outside the power station, which is connected to power lines. #helping. While you don't, I'm just going to look at my coal through my hand lens because I don't know, just everything's better through a hand lens, isn't it? Have you done it? Have you mentioned 3 things? Come on, push yourself. I know we didn't mention coal. You could just say coal, but, you know, you could also challenge yourself. All right, should we go through the answer? Yeah, did you get the printout from my Facebook group? Are you just sort of scribbling on it? Okay, here we go. Well, you've got the coal in this big grey sort of scuttle, whatever it is here, where the coal is kept. So yeah, if you got that, fair enough. The coal is burnt, which we haven't mentioned. So you might have wanted to put that on. The water is getting heated. The water is the thing in these little tubes, and the tubes are right above the fire. So that's where the water gets heated. Those little clouds are the steam. And the steam, well, it doesn't look anything like a windmill in this diagram, but you hopefully gathered that that egg timer on its side is a turbine because the steam is hitting it. So that's making the turbine spin around. And the thing just after the turbine is the generator. What we didn't mention, which is incredibly important, and we're going to totally ignore it this lesson, is this thing called a transformer, which is just outside the power station. Again, we will talk about that pretty much the same time we talk about how a generator works, actually. It sort of changes the voltage to make it more efficient. This swimming pool type thing at the bottom, this is a condenser. It basically, again, it helps the whole process be more efficient, but it sends liquid water back into the furnace. You see there's a tube attached to this pool of water going back into the furnace. So you reuse the water over and over again. And this thing, did you get that? Where all the smoke is going up. That is the chimney, because burning coal releases pollution, which we will discuss very soon. All right, so fascinating fact about power stations, if you didn't know this. If you've ever been past a power station, there's one quite near me, the Drax power station, if you get the train from York. You see huge funnels with loads of stuff billowing out. These are not the chimneys. These are cooling towers. So all that stuff in the air, that's not the pollution, actually. That's the water vapour. It's kind of part of the condenser, is the cooling tower. This is the water vapour that isn't getting reused, escaping. This thing, like skulking in the background, this is the chimney. So that is giving off pollution. All right, so I asked, what do these events have to do with fossil fuels? Was people clapping outside their house at 8 p.m. every Thursday during lockdown and a famous episode of EastEnders? What do they have with fossil fuels? Well, we all like to imagine, don't we, that we're all special and unique and individual, but we're not. We're behaving exactly the same as everyone else in our country all at the same time. So if you worked at a power station and you were looking at, I don't know, the computer, the screen, you would probably very easily be able to tell what time it was, even if you didn't know, because everyone uses energy at the same time. Everyone wakes up and immediately uses loads of energy, like, I don't know, filling the dishwasher or making toast or boiling the kettle. And apparently, during lockdown, when everyone went outside their houses to clap, they would immediately go back inside and make a cup of tea. So you see this huge spike where suddenly everyone in the country is using loads more energy. And especially in ye olden times when I was young, when you could only watch live TV, famously like the ad breaks on the really popular TV shows, all the power stations would have to be ready for a huge surge of energy. And the episode where his ex-girlfriend admitted that she'd killed Phil, was really popular, and after it finished, everyone made a cup of tea, which is, one of the biggest spikes that Britain has ever known. So this leads us to the huge advantage of fossil fuels, is that they can generate a huge amount of energy at very short notice. They are very reliable, right? If you've got a certain amount of fossil fuel, you got it. You can use it whenever you like, and it can be ready to be used very quickly. We're going to look at the wind in a second. Obviously, the wind is not always blowing. So if someone confesses to a terrible crime on the telly and it's not windy, then what are you going to do? No one would be able to have cups of tea. It'd be a disaster. So they're two slightly different things. They can generate a huge amount of energy at short notice, kind of on demand, and they're also very reliable, right? If you've got them, you've got them. But the disadvantage, which I'm sure you are aware of, is that they give off carbon dioxide. If you're writing in your GCSE, it's always better to name a pollutant instead of just saying pollution. Sometimes that doesn't get a mark. So they release carbon dioxide and other greenhouse gases, which are causing Earth to heat up, right? Causing climate change. Also, they're going to run out, which leads us to these words renewable and non-renewable. If an energy source is renewable, it will not run out, or it gets like replaced faster than we're using it up. Coal and oil and gas, definitely non-renewable, will run out really surprisingly soon. We've got a very limited supply. It takes millions and millions of years to form coal, and we're burning it in just hot seconds. So yeah, coal, oil, gas, the fossil fuels, non-renewable. Clues in the word. Takes a long time to make a fossil. So, I can hear you asking, is there any way of getting all the benefits of fossil fuels, but without any of the negatives, like the carbon dioxide and the running out? Well, let me introduce you to biofuels. Biofuels is kind of a weird idea. Biofuels are, well, they're crops. It could be wheat or sugar. Quite often it's trees like wood chips that you just grow them and then you burn them. You're looking at my PowerPoint because of the special effects that are coming. You ready? So they do release carbon dioxide, obviously. Trees release carbon dioxide when you burn them, but they're said to be carbon neutral because you're only releasing what they just took in. So obviously while this wheat is growing in the field, it is taking in carbon dioxide. That's what plants do. They take in carbon dioxide and water and they make their own food. But we haven't had a burning effect on theoscience for ages. So when you burn that wheat, you do release carbon dioxide, but it's only the carbon dioxide that it's just taken in. So you say it's carbon neutral. That's the positive. The negative is it takes up a lot of farmland that could be used for food. Like, you know, farming has a lot of problems attached to it anyway, doesn't it? There's a huge amount of people in the world. You got to feed them all. It takes up a lot of space. Like, do we really want to be just growing crops and then just immediately burning them? It feels weird. That's not science. Don't write that in your IGCSE. So what about wind turbines? Well, that's a great idea, isn't it? The clue's in the name. Wind turbine. They're turbines. So it's like what we just talked about, this process, except you don't need any coal. You don't need to heat the water. There's no steam involved. You just cut straight to the turbine, right? A wind makes the turbine go around, and that's attached to a generator. Yes. So there's loads of advantages to wind turbines. There's no carbon dioxide produced. I've put while they're running because obviously you need to use electricity to actually make a wind turbine in a factory and drive stuff around. But while they're actually running, they don't produce any carbon dioxide. And the land below, unlike biofuels, can even still be used for farming. I mean, are there any downsides? I'm not really asking. What are the downsides? What downsides can you think of? If you're a really lovely person, you might be saying they kill birds. They do kill birds. We're sort of looking at ways to stop that happening. I'm not, but scientists are. You probably won't get a mark for it on your GCSE, so we're not going to talk about it. They do kill birds. They don't kill as many birds as cats do. Yeah, think of something else. Well, are there any downsides? Here's Phil Mitchell with the answer. Unfortunately, yes, there are. They're unreliable. At the moment, it seems weird. You'd be like, just build a big battery so that when the wind is blowing, we can store the energy. That's just not how it works. Like the national grid, which is kind of where our electricity is just not big enough in the UK to store energy generated by wind farms. Like it's a massive amount of energy that you'd have to store somewhere. They're looking into solutions, but at the moment it's just not doable. So yeah, if something happens, you know, if England get into the World Cup and everyone wants to watch it live and you need that massive amount of energy, if it's not windy, that's going to be a problem. Also, it's so that's not having it on demand, but yes, it's also not reliable. Like, you know, if you've got X amount of energy, electricity you need to generate, in the year, and you get 6 months of the year where it's just not very windy for reasons. This is obviously a problem. But also, this is kind of worth a mark often, they can be very noisy. If you live really close to them, wind turbines can be quite irritating. So, last one. There is another one. Will this solve all our problems? Obviously not, or we'd be all doing it straight away. This is geothermal. That's probably my favourite one. It's just a cool idea. So you need steam to drive a turbine. Instead of burning fuel to get steam, let's just dig into Earth, right? The Earth, centre of the Earth, is very hot. And there are places on Earth where the hot rocks are kind of quite near the top. So you just dig down, you send water down into the rocks heat up, get the steam, and then you drive the turbine that way. What could possibly go wrong? Well, I mean, it's very reliable. Like, those hot rocks are not running out. Doesn't take up very much space. These sort of power stations where the geothermal energy is, electricity is generated, yeah, they're smaller than your traditional power station. The problem is, come on, what's the problem? 10 seconds. Think of one. Think of them! You're going to have to think of it in the exam. You're actually thinking of one. You're not just like, oh, I'll just wait. No, brain exercise. You exercise that bit, then when you're in the exam, you'll have made it stronger. Well, the problem is, it's just a picture of London here to illustrate, not that many places you can do it. There's not many places where the hot rocks are there, and there's even fewer places where it's convenient to dig right down and put a load of water into the ground. The other more sinister thing is that there's a lot of gases trapped in the rocks. That's been trapped there for a very long time, and the water releases it all. So carbon dioxide is down there, and something which ends up being sulfur dioxide, which causes acid rain as well. So you could put polluting gases or carbon dioxide, if you want to make a clearer example, is one of the downsides of geothermal. Right, wasn't that a lot of talking from me? I've got a sheet here for you. If you have downloaded the sheet from my Facebook group and you're filling it in, can you just add releases carbon dioxide on the side? Because I forgot, sorry, quite a big downside to quite a lot of ways of generating electricity. So here we go. You've got the things that we've talked about today. Fossil fuels, biofuels, remember the crops that you grow in Mumbenham, wind, and geothermal. You've got loads of disadvantages and advantages on the screen. Can you match them up? So which of these are the advantages and which are the disadvantages that you would get a mark at GCSE if you wrote them? Like, obviously, if you use fossil fuels, the land can still be used for farming, but that's just kind of not a relevant point, right? It doesn't match fossil fuels, so you wouldn't get a mark for that, so don't say that. Which of these, if they say in an exam, give two advantages of fossil fuels, what could you write down? You get me. I'm gonna be quiet. I'll give you 2 minutes for this. Should say, as usual, if you are watching live, there is a post on my Facebook page saying, if you're watching live, say hello here. So if you're watching live and you are on Facebook, you can go over and leave me, I don't know, angry messages or questions, whatever you want, really. Should we go through the answer? All right, let's see. Fossil fuels. Well, the classic advantages are they can be used on demand. It's very fast. You can if you suddenly need a lot of electricity in a country, then it provides it very quickly. And they're also very reliable. And the classic disadvantage is that they release carbon dioxide. Wait, I haven't put one on here. That's an extra question for you. Which downside to fossil fuels have I not put on here? Biofuels. Well, they are carbon neutral. So they take in carbon dioxide and then they give it out. So yeah, overall, there's sort of no effect. But they do take up loads of farmland. But they can be used on demand, and they are pretty reliable as well. Wind turbines mean that land can still be used for farming, so that's good. But you can't have it on demand. They can be noisy for people living nearby, and they're pretty unreliable. But they don't give up any pollution, carbon dioxide, so that's good. And geothermal, it's difficult to find suitable places for it. And it does also release carbon dioxide. Did you get that if you realise that makes more nutritious flour was a nonsense one that I threw in to try and trick you, well done. You are doing better than Donald Trump, actually, hopefully not future president of the United States. He, in a speech, was talking about windmills, meaning wind turbines. So wind turbine, spinny, generates electricity. Windmill, quite an old-fashioned, beautiful thing, still have them sometimes, turns in the wind, makes the flour. So we're talking about wind turbines. You will not get asked about windmills in your GCSE physics, so don't worry about that. And it can be reused again and again. This is a classic mistake that people make at GCSE, is thinking that renewable energy means it can be reused again and again. Renewable means it's not going to run out. Don't say, I should stop saying it so you don't remember, it can be reused again and again. Like that gust of wind is gone, but it's not. The wind is not going to run out, okay? Right, I've got some GCSE questions for you here. They do ask you for two advantages. I'll keep you hanging. Hopefully you can remember if you need to know two disadvantages of fossil fuels, then you've got them. But let's have a go. To end, here we are. Right, first question. You've got a power station here. Which part of this power station transfers energy from a chemical store to a thermal store? Probably the hardest question, isn't it? Which part of a power station transfers energy from a chemical store to a thermal store? Is it the boiler? Is it the turbine? Is it the generator? Or is it the condenser? Question number 2. And which part transfers energy electrically from a kinetic energy store? Again, boiler, turbine, generator or condenser. Can you name one fossil fuel? Can you give 2 advantages of using wind turbines for generating electricity compared to using fossil fuels? So 2 advantages of using wind turbines compared to fossil fuels. It's quite clever that they've said that, isn't it? It means you can't just write, doesn't take up farmland. Because if you might have memorised that about wind turbines, but it's not an advantage compared to fossil fuels, because neither of them take up farmland. And finally, one disadvantage of wind turbines compared to fossil fuels. One reason why fossil fuels are better. How are you doing? It's been a fast lesson, this one, wasn't it? That's the nice thing about not being at school, is that I don't have to time them. I love that. I love that I don't have to keep looking at the clock and thinking, oh no, the bell's going to go in a minute, oh no. But I do tend to go pretty fast on YouTube. Should I go through the answers? Yeah, is that right? Not too fast, was it? The part of this power station that transfers energy from a chemical store to a thermal store is the boiler, or the furnace, the bit where the coal is burned, right? Because the coal, careful really, the coal plus the oxygen together are a chemical store, and when they're burned, their energy gets released and transferred to the thermal store of the air, but also of the water. Question 2, which part transfers energy electrically from a kinetic energy store? That's the generator. So the generator's kinetic energy store, it's sort of, energy is carried away via the electric pathway, right? Name one fossil fuel. Hopefully that was all right. You could have had oil or coal or gas, just those 3. 2 advantages to using wind turbines compared to fossil fuels. Well, the big one is they don't give off any carbon dioxide. And they won't run out either, that's good. Well done if you thought of any more. I can't think of any more. No carbon dioxide will not run out. And one disadvantage is that they are unreliable, or you could have said you can't have it on demand, or you could have said they're right noisy as well. Not that I think anyone really wants to live next door to a power station, but yeah, I think wind turbines can be particularly distressing. Right, I'm going to go over to my Facebook page, see if any of you have said hello, and then I'm going to go and start planning next week's lesson. You're going to come up here with me. Hello. So yes, that is the end of the lesson. You are totally free to go. If you want to support me, if you're using these lessons and you're like, oh yeah, she deserves paying for her job, you totally can pay me for my job. You can go to my About section. I always do that. I need to work out where it is. I don't know where it is. But if you're on YouTube, there's a little About tab. And if you click it, it takes you to this website where you can send me £5 a month. It is an incredible business model. I just do everything free. The printouts are free. There is currently, right now, in my Facebook group, a PDF with some past paper questions in it that I think you should be able to do once you've done this lesson. So if you've done the lesson, just go to my Facebook group right now and get the homework PDF and then do your homework. You know, if you want, it's up to you. But yeah, all that is free, and people send me £5 a month, and I send them a Theatre of Science magazine to say thank you. So it's just like, it just comes out whenever it comes out. Basically, you're contributing to my wages, and I put this in the post for you every time I've written it. So this one is on weeds. If you sign up with £6 a month, I'll send you this one. If you sign up with £5 a month, I'll send you the one on mould, which is also very good, if I may say so myself. So they've all got like quizzes and activities. I say they're for all ages. I mean, none of the information in Theatre of Science magazine did I know before I started writing it. And I'm a physics teacher, so even if you're doing IGCSE, I think there'll be something in here that you will really like. But if you don't want the magazine, you can sign up to support me and not get the magazine if you want. I mean, I don't know why you would, but you can. You can turn down the magazine if you wish. Yay, comments! Oh, it's Otto! There is also hydropower. Yes, Henry. Next week, we're doing all about basically all the water options. So the damming and the waves and and the tidal. We'll do water next week. Well spotted. Oh, Layla, solar panels. Yes, exactly. So this is, I should have said, we've done some of the alternatives today. But next, we've still got 2 lessons left. So yeah, you're absolutely right. We'll do solar panels and all the water ones. Oh, and nuclear as well. Got to do a bit of nuclear energy. Where is the coal coming from? Oh, hello, Kyle. You should do this lesson on Facebook. Yeah, I did yesterday. It went horribly wrong. In fact, we had to come over to YouTube. It went so horribly wrong. Where does the coal come from? Coal mines. And before that, very, very ancient trees. Starter question equals confusing. Good, Henry. I'm glad. I'm glad that you were confused. Hopefully you're not confused anymore. All right, so Layla and Henry. Yes, excellent suggestions. We will get to all those. Otto, thank you very much for coming. Otto, is any more? No, I think you're just all coming up with the excellent suggestions. Good. All right. Well, I'll get going then. I might see you if you like YouTube. I'll see you tomorrow on YouTube for the Lego Storytime show at 10:30, or the all ages lesson on how you predict the weather at 9 o'clock, or next week for more IGCSE. See you soon. Bye.